right, pre-calculus class. We left off on page 140 and I wanted to cover two more important points about polynomials. The first one is the remainder theorem. The remainder theorem is an interesting little theorem, and it is if you were to divide a polynomial by a number and there is a remainder, or even if there isn't a remainder, the value of the remainder is the same as the value of the function at that point. So let's walk through this. Example 5 says, use the remainder theorem to evaluate, here's our function, when x equals -2. So we could do this very simply just by putting in x equals -2, figuring it out. We could also put that in our calculator and use our calculator to find the value of the function when x equals -2. So this is just one more tool in our tool belt. What we can do is we can divide synthetically by x equals -2. Notice that we're using the same number. We're not switching any signs. So let's do this synthetic division just to remind you how to do it. I'm going to grab the coefficients off this polynomial, 3, 8, 5, and -7. I'm going to double check that I have a coefficient for each degree. So degree 3, 2, 1, 0. Good. I want to divide by x equals -2. So I put the -2 here. They write it a little bit different in class. I put that in the little box. And then I drew a line right here. Okay, so the very first coefficient, we drop 2 lines. Then we multiply and we add. We multiply, we add. We multiply and we add, and this is our remainder. So the remainder theorem tells us that if we put in -2 for x, we would get -9. Interesting, right? That's from the remainder theorem. And in fact, they show you that that's how it comes out. So how useful is this? Well, I don't know if it's very useful, but it's something that we need to know for calculus. The second point that we need to finish in this chapter is the factor theorem. This is something that's not new. We've said it in class. A polynomial f of x has a factor x minus k if and only if f of k is equal to 0. Or in other words, when you divide by k, you would have a remainder of 0. So let's take a look at this. Example 6 says, show that x minus 2 and x plus 3 are factors of this polynomial. So we're going to do synthetic division to do this and see if we get a remainder of 0. So for dividing by x minus 2, switch the sign, use a +2 in the little box. Grab the coefficients 2, 7, -4, -27, -18. We have a degree 4, 3, 2, 1, 0. We're all set to go. So drop the 2, multiply, add, multiply, add, multiply, add, multiply, add, and we get a remainder of 0. That means that x minus 2 is a factor, or that f of 2 would be our root. These all mean the same thing. Previously, last year, you would have set this equal to 0 and found that x equals 2 is a root. Now this is something a little bit interesting. If x plus 3 is a factor, we can use the original polynomial, or we can use the coefficients in what we call, this is a depressed polynomial. This is a polynomial of degree 4, and we know that the answer is a polynomial of degree 3. This is sort of like using the factor tree, doing a factor tree. You got some large number, you know that 2 is a factor. Now we want to know, is x plus 3 a factor? You can use the part that's left, the other factor that's left. So that's what they're doing here. You could have gone back and used the original numbers. It still will work. Okay, we're trying to show that x plus 3 is a factor. That means that x equals negative 3 would be a root. So negative 3 is out front. 2, 11, 18, 9 from the previous problem go. Drop down the 2, multiply, add, multiply, add, multiply, add, and we get 0 again. So the resulting quadratic expression factors as 2x plus 3, I'm sorry, this right here is 2x squared plus 5x plus 3. That factors into 2x plus 3 and x plus 1. And we had the previous two factors, so now we have a complete factorization of a polynomial, something that is very worthwhile to find. I'm just going to take a minute and factor this with you guys using that method that I used in class today. So we have 2x squared plus 5x plus 3. I'm going to use the crisscross method. This is A, B, C. On the top here is A times C, which is 6. On the bottom is B. We want two numbers that multiply to 6 and add up to 5. That's going to be 2 and 3. So now we rewrite this as 2x squared plus 2x plus 3x. Remember, we divide this into 4 terms and then go back up here plus 3. So notice this polynomial is the same as this polynomial. Instead of the 5 in the middle, we got 2 plus 3. And then now we're going to factor this by grouping. Greatest common factor, 2x. Greatest common factor here is 3. The last step in factoring by grouping, pull your front parts off. That's one factor. Pull the second, which is common to both. And that's how we can factor this polynomial, this quadratic, into that. It's just to help. You don't have to do this. You could do guess and check and get here. All right. As always, please let me know if you have any questions.